So our notes today on solving exponential and logarithmic equations, most of it you have done before in Algebra 2. There are a few things that we'll look at that are slightly different than maybe you saw in Algebra 2, so I'll kind of make note of those as we do our notes. This is an important section. It's going to lead us into our notes tomorrow, which is using models of exponential and logarithmic functions, so to apply to like a real-world scenario. And so we want to be able to solve equations so we can find things using those models. So they kind of coincide with each other and go along nicely. The first two slides of our notes today, you'll just be jotting down some tips for solving the different types of equations. Our first one is solving exponential equations. So I'll just give you some time to jot a few of these tips down, then we'll talk about what they mean. So we already solved one exponential equation in the warm-up. Bailey did that for us on the board. And what she was working with was something very similar to the first bullet point. You've got one exponent in the whole equation. The variable is in that exponent. Try to get the base and the exponent all by itself so that you can rewrite it as a log. And so that's probably the one that we're most comfortable with. There are some other scenarios. One of them we've already seen. What if they have the same base and I could get them on different sides of the equations and then just use my one-to-one property? And so we've already seen that, and you did one-to-one property last year as well. The other case that's probably new to you from Algebra 2 is what if they have the same base but you could factor the expression? So we'll look at an example together where we have to factor the expression to solve. And then also new to you is what if they have the different bases? So I would say most Algebra 2 classes probably didn't talk about that last one. If you did, it was like as a side note because somebody asked about it. So that's kind of where we go one step further in pre-calculus. I say take the natural log of both sides and then use your properties of logs. We'll look at an example what that means. But note that you don't have to use the natural log. You could also use the common log or any other log as long as you took the same base log on both sides. I suggest natural log or common log because those are in your calculator, so they'll be easy to evaluate at the end. And then I've always just been taught to use the natural log, so that's what I do. But it could be any log. Take the same log on both sides. Here are some tips to solving logarithmic equations. So again, I'll give you just a little bit of time to copy that down. very similar to exponential equations. Logarithmic equations, your variable is trapped inside of the log. If you have only one log in the entire equation, you're going to try to isolate that log. Remember that if we talk about isolating the log, that would include the base for the log and then the thing that you're taking the log of, which your x variable is going to be in that piece. Okay? So isolate that and then rewrite it in exponential form. Other scenarios can happen. What if they have the same base? In those cases, try one-to-one property if you can get one log on each side of the equation. If there are too many terms besides the two logs, you might try to condense first. So if you can't use one-to-one property, then one log is better than two logs in this case. So condense and then you can rewrite at the end. And then at the very bottom here, a little reminder for you, if you're solving a logarithmic equation, you should always check for extraneous solutions. So think about the graphs that we did for log functions and how we listed the domain and range for a log function. The range for a logarithmic function is always negative infinity to infinity, so we can get all kinds of numbers out when we do log functions, but our domain was restricted by our vertical asymptote. So there are only certain numbers that we can take the logs of. You can't take logs of negative numbers or 0, I should say. We can't take the log of the number 0. So if you take your answer and you plug it back into the equation, and then the thing behind the log becomes 0 or becomes a negative number, that's extraneous. So always remember, extraneous is different than wrong. Okay? A better word for extraneous would be false. You did all your math correctly, but at the end you plug your answer back in and it doesn't fit into the domain of the function. So it's not a correct solution, or not a valuable solution to us. Okay, let's look at some examples. First example, if you want to jot it down in your notes, you can. I'm going to run through pretty quickly because it's similar to our warm-up example. So you guys showed to me in the warm-up you could solve exponential equations. Okay, 6 times 2 to the 5 minus x plus 4 equals 11. When I look at the equation, I see it's exponential. The variable x is up in the exponent. So I only see one exponent. I'd like to get the exponent and its base all by itself. That means I'm going to have to move all the other numbers to the other side. What would I do first? Subtract 4. Excellent. 6 times 2 to the 5 minus x equals 7. Then divide by 6. 2 to the 5 minus x equals. And over here, I'm going to avoid rounding issues. I don't want to round in the middle of my problem. I'm just going to leave that as 7, 6. Okay. At this point, I have the base and its exponent all by itself, so I can rewrite in logarithmic form. So it's going to be log base 2 of 7, 6 equals 5 minus x. And then most likely you're going to be using your calculator here. So you would evaluate log base 2 of 7, 6. Remember, you could use your change of base formula in your calculator. We did that in notes 3.3, change of base. So log of 7 divided by 6, I got to close my parentheses, divided by log of 2, I get 0.222 right there, equals 5 minus x, and then that's a pretty basic equation for me to solve. Subtract 5, so negative 4.778 equals negative x, and then both sides would become positive, divided by negative 1. Because this is exponential, I don't need to worry about checking for extraneous solutions. The only type of equation here that I would be checking for extraneous solution would be the log, because that's the one that has a restricted domain. Let's look at a second example. Really basic and pretty easy. Natural log 3x equals 4. This is a logarithmic equation. There's only one log in the whole equation, so I'm not going to use my one-to-one property or condensing. You tell me the first step is? Yeah, rewrite it. This one doesn't have any kind of solving reverse PEMDAS that I can do to get started. The log base e of 3x is all by itself, so I'm going to go ahead and rewrite it. Remember, if you can't remember, you can always draw in your little base e there for natural log. So we're saying e to the fourth equals 3x. I'll just have to divide by 3, and I get something like 18.199. This is a log equation, so I should make sure that the answer is not extraneous. And basically, it's like a quick 3 to 5 second check. If I plug 18.199 back in for x, will I be taking the log of 0 or a negative number? No. So as long as I did my algebra correctly, I have the correct answer, and it is not extraneous. The only time I would cross it off and say extraneous is if I try to take the log of a negative or 0. Are we okay so far? Okay, you guys are doing very well. Let's try log base 9 of x minus log base 9 of x plus 1 equals 1/2. Condense it first. So in this one you have 2 logs, but the one-to-one property is not going to work out. If I move log base 9 of x plus 1 to the other side, I still have this plus 1/2. What am I going to do with that, right? So when you have this like extra number, that means you're probably going to use condensing. So this is really going to be the log base 9 of x over x plus 1 equals 1/2. 1 log is better than 2, so use condensing. And now I can rewrite it. So rewrite it in exponential form. That'd be 9 to the 1/2 equals x over x plus 1. Do 9 to the 1/2, which is the same as the square root of 9. And most of us would say if we were solving and we did the square root of 9, we would put a plus or minus 3. So in this case, at this point, because I have the plus or minus 3, I'd be thinking like I really have 2 separate equations to solve now. 3 equals x over x plus 1 and negative 3 equals x over x plus 1. Well, you can have negative answers. Let me write those down real quick. It's not that negatives aren't allowed at all. It's just that when you plug them in, they can't be negative numbers behind the log. So you could plug a negative number in and then it becomes positive for whatever reason. And that would work okay. How would you solve those equations when they look like x over x plus 1? You can multiply by the denominator, or some people might say cross multiply them. Sure. So this is going to be 3 times x plus 1 equals x, and negative 3 times x plus 1 equals x. Pull all of this stuff up a little higher for us. You can see it better. And then I would distribute 3x plus 3 equals x, negative 3x minus 3 equals x, and then those are pretty easy equations for me to solve. So I would get 3 equals negative 2x, so x equals negative 3/2. And then I would get negative 3 equals 4x, so x equals negative 3/4. And at that point, that's when you start checking your answers, right? So it is a log equation. You should have distributed the negative 3 to x plus 1, so it would be minus 3. Do those numbers work? do the log base 9 of negative 3/2? No. Can I do the log base 9 of negative 3/4? No. So they are both extraneous. It could be that both are extraneous, one is extraneous, both are actual solutions. You don't know until you plug it back in and test. And you have to go back to the original, not to the condensed. Okay, so because that very first one is just log base 9 of x, I would cross off both of these and say they're both extraneous, so there is no solution. If only one is extraneous and one still works, then you don't have to say no solution. When you plug the number back in, you're trying to take the log of 0 or a negative number. So I didn't even have to go further than this very first log in my original problem. Log base 9 of x. If you put negative 3/2 in, can't do it. Put negative 3/4 in, can't do it. One other one just really quickly, and I'm not going to work out the whole solution here, but just kind of give you an idea because you'll see one like this on your homework. Natural log x plus natural log x plus 2 equals 1. You would tell me to start by condensing it, right? So that would be the natural log of x times x plus 2 equals 1. What would you tell me to do next? Okay, I could distribute my x's, sure. So that's the natural log of x squared plus 2x. And I'm going to put that in parentheses because that's all behind the natural log. What else? Rewrite it. Base e, right? So this is e to the first equals x squared plus 2x. How do you solve an equation that has an x squared and a 2x in it? What's that? Okay, one option I heard is factor. In order to be able to factor an equation, what must be true about it? Must be equal to 0, so I'm going to move my e to the other side. 0 equals x squared plus 2x minus e. Are you going to get factors of e that add to make 2? Or negative e? No. So if you can't factor it, what do? Quadratic formula. Yep, don't be shy, right? Quadratic formula. So at this point, I'm not going to work out this whole piece, but this one you would use quadratic formula. So if I set up quadratic formula, it would look something like x equals negative 2 plus or minus the square root of 2 squared minus 4 times 1 times negative e divided by 2 times 1. So my A is 1, my B is 2, and my C is negative e. I would hold off for as long as possible on evaluating my e, so I might do this stuff underneath. X equals negative 2 plus or minus the square root of, this would be 4 plus 4e all over 2. And then I might start to do my calculator work. To kind of simplify that out. And in my calculator, when I want e, I'm just going to have to pull up the second ln, get my e, raise it, in this case, to the first. There'll be one like that on your homework tonight. So I would say set up your quadratic formula, plug it into your calculator, see if you can get the correct decimal value. Okay, so I'll share those answers tomorrow and you'll be able to check it. Okay, any questions on those? We got 2 other ones real quick to look at, and then you're going to do some practice with partners in class. So this one, I don't know that you saw any similar to this in Algebra 2. E to the 2x minus 3e to the x plus 2 equals 0. When I look at this problem to start with, I notice I have 2 base raised to exponents, so immediately I'd be thinking about, could I use my one-to-one property? But then I have this plus 2. That's not going to go with either one of them, so what am I going to do? If you go back to the tips I gave you, if they have the same base, you could try one-to-one property, and if that didn't work, I said factor. So you have a trinomial here. You're going to factor the trinomial. And think thoughtfully here. What will be your first terms in both groups of parentheses so you can get e to the 2x? E to the x times e to the x. Now, if you think thoughtfully, why would you think that would work? Because that's your middle term, right? So you're going to need e to the x terms to get minus 3 e to the x. Think about e to the x times e to the x. What would you do with your exponents right there? Add them, e to the x plus x, that's e to the 2x. So sure enough, e to the 2x is e to the x times e to the x. Do you have factors of positive 2 that add to make negative 3? Negative 2 minus 1. Now set those factors equal to 0. So once you figure out the factoring piece and that, like, to get e to the 2x, it's got to be e to the x and e to the x, it actually works out real nicely. Pretty easy to solve. So I would add 2 to both sides, and then I'll rewrite it, natural log 2 equals x. Add 1 to both sides, natural log 1 equals x. So this one is 0, and I think this one is like 0.693. And again, there'll be some like that on your homework as well, so you'll get an opportunity to practice those. Okay, last one. This is definitely new to most of us, unless we had those classmates or that person who asked your algebra teacher, what do I do if they don't have the same base? 3 to the x equals 7 to the x minus 1. You know, we might have tried previously in notes 3.1 to try to get the same base. Can I rewrite 3 with base 7? Can I rewrite 7 with base 3? They don't really have any common factors, so I'm not going to be able to do that. So in our notes I said, take the log of both sides. And I specifically take the natural log of both sides. Doesn't matter if you choose natural or common log. So if they don't have the same base and you can get them to have the same base, take the natural log of both sides. And at first you might be saying, that doesn't really look so awesome. I don't know why I would want to do that. Use your property of logarithms now to say that these exponents are really coefficients of the log. They get multiplied in front of the log. So x times natural log 3 equals x minus 1 times natural log 7. Now, do you agree that the natural log 3 is really just a number? Okay, and natural log 7 is really just a number, but they're both some kind of decimal, right? So we're going to avoid writing them as decimals for as long as we can, but just always reminding ourselves that's really just a number. So if I had something like 3x equals x minus 1 times 7, what would I have done next? I would have distributed my 7 into the group of parentheses. So that's what I'm going to do with natural log 7. I'm going to take natural log 7 times x and natural log 7 times negative 1. If those were just like numbers and they didn't look like natural log, if it just said 3x equals 7x minus 7, then I would have moved my x term to the other side, right? So I'm going to subtract natural log 7. Now here's the difference. If I had done 3x minus 7x, I'd be able to get negative 4x. I can subtract those. I can't subtract x natural log 3 minus x natural log 7. Those are not like terms. Okay, so I'm going to write it out as x natural log 3 minus x natural log 7. And then over here I just have the number negative natural log 7. what I can do on the right side now, and this kind of reminds me in chapter 1 when we were writing inverse functions for rational functions. What do both of these terms have in common? X. So factor out x. If that was 3x minus 7x, I could have factored out the x and done 3 minus 7 to get my 4. So they just happen to be natural logs. And now to get x all by itself, I just divide by that thing, right? Whatever natural log 3 minus natural log 7. You could condense this, correct? Right, so if you want to condense it, you can. I usually, at this point, I'm so close, I just divide. Okay, but if you want to condense it, that would be fine. That less typing, I suppose. And so in my calculator, I just have to type all that. Now, you get something very similar if you rounded, but we want to try to avoid rounding for as long as possible. Questions about where I got something in my work? Yeah, you'd need to have this denominator in parentheses so that the calculator will subtract it first. I know that that's hard, like the first go-round to like follow everything, but I want you, when you're doing your homework or you're doing your activity here in just a minute, when you solve that particular set of problems where they don't have the same base, you know, try to think about what you would do if they weren't logs.
How do you do that? How do you get negative? Oh, because I forgot parentheses.
Yeah, parentheses are going to be super important.
So you have to like.
There will be a parentheses like usual, like this. And then you have to open this parentheses for your denominator. And then you'll have like this. Oh, there's a lot of parentheses in there.
And it puts parentheses naturally.
I know you can do it. I know that you need practice with it, right? Okay, you need an opportunity to do it on your own. So you'll have that in the activity you're going to do here shortly and also in your homework. Okay. If you got really, really stumped, you could round the natural logs, right? Or you could write out a lot of digits for the natural logs. And then you'd be working with more like numbers if the natural logs were really messing you up. Okay, what you're going to do next is work with a partner for an activity.